Hi, welcome everyone. Azure Cosmos DB Live TV, episode 18. This week I'm joined by Lena Hall. Hi, Lena, how are you?
Hi, Mark. I'm doing great. How are you?
I'm doing fine. So good to see you. Thanks for joining us this week.
Good to see you too. Thank you for inviting me.
You
It's
bet.
such an amazing show.
Thanks. I'm trying my best to create cool new content around Cosmos and distributed databases, NoSQL databases, all that stuff. So yeah, you want to. So for the folks that don't know who you are, you want to introduce yourself and just tell us a little bit about you and your background and everything.
Absolutely, yes. As you already mentioned, my name is Lena Hall. I do things with data and analytics at Microsoft. I work a lot on strategy for product improvement for various Azure products that we have, as well as content and awareness, helping the community find the best solutions for them. So I've been in this role for quite a few years, but in the past I come from an engineering and architectural background. So I'm always fascinated by distributed systems, by data architectures, by anything that you can do with the data, machine learning, data science, analytics, and anything like that. So, and I think this is a great topic to talk about today.
Yeah, I think I mean, thanks for being here and coming. You know, I've wanted to reach out to you for a while and just kind of invite you on and just to talk about kind of just general topics about cloud and databases in the cloud. And I know you're a big distributed systems person, and I just thought it'd be great just to have you on and we could just talk about kind of things you're seeing in the cloud and the database space these days, the kind of trends that are happening. I thought we could have a kind of a conversation around that. So, I mean, I guess just kind of ask the question: what are the kinds of trends and things you're seeing out there today in kind of the cloud and distributed systems and databases space?
I think there are too many to count, so we could talk about this for a whole day, but we can absolutely cover some of them, during the next hour or so. So,
Sure.
I think the theme is that we have a lot of help, like we as engineers, as architects, we have a lot of help from the cloud itself to implement things that we are building. So if we just look a couple of years back, building things in the cloud becomes much easier because of additional abstractions and things that teams like your team, for example, are implementing to make life of developers easier. And there are a lot of many complicated concepts that are implemented in the cloud that people don't have to really think about when they use things like Cosmos DB or like other managed products. Only if they usually if they manage those systems themselves, they have to usually keep track of distributed systems concepts and understand them in more detail. I mean, when you work with Cosmos DB, you still need to be aware of things like consistency because you need to make some choices and trade-offs. But when you think lower level about the concepts in distributed systems, I know that we at Azure are always improving things like failure detection or reliability to make sure that, when people use our databases and distributed systems, they can rely on them and they can make sure that if something goes wrong, we'll take care of it if we stated that things will work. So, and this has been the topic of one of my articles that I wrote for InfoQ recently with the help of people like you and people from Service Fabric team that talks about the concept of failure detection. So if that's interesting, we can dive into this a bit more.
Sure. I just put that. I read that. I mean, what a great article. And I know you talked to myself and Andrew. Oh, and I guess others from our HA team as well about how we were implementing or what we were doing in the area of failure detection. Because like you said, we build Cosmos so that people don't have to. Right? It's why it's this managed service that provides this NoSQL distributed database environment for people. And cloud in itself is really kind of, at least this generation of it, you have kind of the first generation of just VMs and being able to virtualize that way. But now you've got this new set of managed services that really handle a lot of the things that you would have to have built yourself, like failure detection, and replication, and quorum management or consensus management. All these things that you need in a distributed system, and are there for you in a cloud, in a point and click manner, which is fascinating. And I think it's awesome. It's providing real value for people, so they can take advantage of the cloud. Because why would you build a distributed system? It's because you can get greater availability, or maybe lower latency for users that are nearer to the nodes and the data where it's located. So anyway, I kind of lost track of what we were.
I completely agree. And you were saying that this is already implemented for us, and we can focus on like other more important things. I have definitely seen interest from people who are the users of our distributed databases, even though they don't really need to know what's happening behind the scenes. I know a lot of decision makers prefer to be aware of how things are implemented, and to keep track of what mechanisms are we using to keep things up and running, just for awareness. And sometimes they do make decisions based on Cloud A is doing one thing, Cloud B is doing another thing. So just having that insight, I think, can help create more transparency into how we're building the systems. And of course, there are white papers that describe various aspects of, all sorts of implementation details, of course, that are sometimes adjusted in the practical implementation, but it's very close to reality. So basically, even if you don't really need to know about these things, it's usually good to understand the full picture of how the service is running. So basically, if we think of Cosmos DB as a managed solution on top of Azure, it needs to keep track of the replica sets. It needs to keep track of the data that is being replicated. It needs to make sure that when the users make a request, the data is available. And of course, because you have different consistency modes, it can tweak the level of consistency and availability based on what you need. But even with that, there are multiple levels in which failure detection is handled. So, for example, there is first the theoretical notion of failure detection that is applied to so many distributed systems. And to understand it a bit more, I guess we can decompose it to the definition and then some properties that come along with the definition. So a failure detector is a mechanism that allows nodes or machines in a distributed environment to see failures of other nodes. Mm-hmm. And it doesn't necessarily help resolve the situation. It just makes sure that there is awareness around that, and we can then come up with a solution that could fix the issue. There are multiple properties that affect that the strengths of the failure detector, I would say. The completeness and accuracy. So if some or all of the nodes can detect all of the failures in the system, and then how precise are these nodes in their suspicions. So some systems theoretically could be running using the perfect failure detectors, which means it never makes mistakes. All the nodes see the failures immediately, which is a brilliant concept, but it
sounds very theoretical, actually, in my mind.
Exactly.
Perfect anything in a distributed system sounds no.
It's not possible in real environment, because we can't make any assumptions about timing and about the nature of like message delivery, because we do know that we're sending a message, we don't know exactly when it's going to arrive. So the nature of our environments is usually very asynchronous, which means that we have to make some sacrifices, and we need to make decisions to acknowledge that, you know, there will be a time during which we don't know if the node is up or down. We can suspect it, and we can see if, you know, it is really failed or if it's just unavailable for some time. But eventually, after a certain period of time, we need to figure out what is our next step. Do we want to exclude it from our quorum, or do we want to wait more? And I guess this is where the practical implementation comes in. So at Azure, we have this amazing system called Service Fabric, which implements so many of the distributed systems concept. And a lot of our products rely on it for various things like leader election or failure detection, just membership. And Cosmos DB is one of those services that uses Service Fabric for the detecting failures within a region. But then the interesting things comes up when, you know, because Cosmos DB is a global database, it doesn't live in one region. So it needs, you know, the cross-region failure detection as well. So it does implement additional mechanism to identify these failures using an eventually weak failure detector, which it sounds like it's weak, but it's actually not. It is very effective. It is very helpful in identifying large-scale cross-region failures, and that is on the server side of things. But then we also have the client side mechanisms to recover from failures in case, you know, we need to make sure the customer don't notice there's a failure. We just redirect them to a working copy of, you know, our environment. So it is a very interesting topic. So I would say if people are curious about the minute details of it, go check out the article, and always happy to like dive into more details.
I think it's great. You know, you touched on a couple of words that triggered me there, like asynchronous, right? Because in a distributed system, everything is across a network, right? This is where all the problems come from, is you're relying on a network, on a WAN in most cases. And networks are notoriously flaky. I mean, you don't know what can happen. I've said this before, I think, on the show, but you can have anything from like a network card failure to a router or a switch fail to some guy drops a boat anchor on a transatlantic cable in the Suez Canal, which, by the way, has happened, to knock out your WAN, your network. And the other thing too is you touched on this with you know, perfect accuracy or weak accuracy is sometimes failures are transient and they're just little hiccups. So you can't go for perfect consistency because you may mark a node as failed when it's really not. When a retry maybe would have solved the problem, right? And that's the trick is, yeah, you can detect these failures. What do you do with them? How do you respond to them is kind of the real key. And it's in fact a question we get from customers that want to understand better how Cosmos is architected and built, is how do you handle, say, local replica failures and recover from that? Because if it is transient, then you don't want to destroy the node and rebuild it, rehydrate it.
Yeah.
That takes time and also you know, cost, I guess, although we don't care. Versus failing a region, which is a much bigger issue.
Yes, and I think another thing just to highlight is that failures happen all the time, and the main thing is, as you mentioned, that the users won't notice it, and that's the main thing that like our teams are working really hard to do.
Yeah, I mean that's true for us. You can lose a physical partition or a replica, and because we have we write to 3 out of 4. We maintain a 4 replica set. You can lose one and still not lose availability because you still have the other 3 you can write to, and of course reads you wouldn't lose either. And then the same thing on the client side too, right? Like if you lose writes, that's one thing. But if you lose availability on reads, we'll just retry the read in another region. So you may see some latency, but you won't lose any availability, and you may not even notice.
Yes, yeah, absolutely.
So,
and another interesting thing is like when it comes to Service Fabric and how it helps Cosmos DB is that Service Fabric, Cosmos DB and Service Fabric can actually stop some of the internal operations that like Azure maintenance is trying to do with our nodes. If there is something critical happening and is requesting, to move the workload from one node to another, we can just push back and say, no, it's actually really critical and we're not going to do that. It's another cool thing that it can do.
Yep. Yeah, because it knows where kind of all your fault domains are, or update domains are going to be as well. So it can say, hey, don't do that. You're gonna impact availability for some customer there.
Yes, absolutely.
Yeah, cool. What's some other stuff we could talk about? I saw another article you wrote on sharing data.
Oh yeah.
That I thought was fascinating. Let me put that one up as well. People should check this one out too. This was also, sorry for the long URL. I'll leave that up for a while so people can dutifully write it down.
Yes, please be very careful and type all the letters into your search bar. But yes, I think that the topic of data sharing has been absolutely gaining traction recently because of the way we organize teams who work with the data and who the consumers are for the data. So usually in many companies, there is like a data lake that aggregates a lot of raw data. And then there is a need to have systems that consume the data. Some of the systems are more like on the operational side, some more on the analytical side. So if we need to have access to the data to, let's say, marketing teams, they need perfectly aggregated, cubes of data from a warehouse. And then if we need some transactional representation, we need to have something like Cosmos DB to provide a really fast way to access that data. And a lot of people are trying to find a way to not have to copy the data or move the data every time they need to access it in different ways. So a lot of this comes from the fact that we have different services that need to work or access the same data. And, in a lot of services right now, the teams that develop it prioritize features that, separate compute and storage to enable that flexibility to be able to mix and match the way we do processing on the data and the way we store data. And I think one of the good examples here where we don't really have to move data is when we're using things like Cosmos DB and Azure Synapse using the link functionality. If you already have the data in Cosmos DB, you don't really have to move it anywhere. You can just do processing on it using the Synapse engines. And this is amazing. You don't really have to pay for the transfer fees. You don't need any additional complexity. And a lot of other products, in other clouds and other cloud offerings are taking this approach. So we can see that in Google BigQuery. We can see that in Presto/Starburst, also in Snowflake. So I think it's moving towards, the industry is moving towards that place where we can easily mix and match the compute engines that can be applied to the data that is, sitting somewhere where it's convenient and that allows access from various places. And I think this is also reinforced by the recent announcement made by at the Databricks summit that happened, I think, a month or so ago, where they have announced the open source Delta sharing. So the Delta Lake sharing open standard, which, it's not really like an implementation, but it's an open standard, making it easier to share data regardless of the computing platforms that are being used. So that's another interesting thing.
Yeah, yeah. I mean, things are evolving, and it's a topic people, I mean, are increasingly having to deal with, because there's just the amount of data is just growing and growing and growing and growing, and people are like, what am I going to do? I've got a petabyte of data sitting in my data lake. I'm not going to replicate that to every single region. That doesn't make any sense. So people are trying to come up with strategies, or just thinking about what's the way to, what's the right approach, and technologies and whatnot to use for getting the data where it needs to be, but also just not doing kind of unnatural things like replicating petabytes of data into different regions when you don't need to do that. I mean, in some cases, like for analytical workloads or where you're reading out of a data lake, you don't need like sub-second latency like you would with, say, a Cosmos, right? There's a reason why we replicate data, all the data, to every region, is because one of the design goals of Cosmos is to provide low latency. It's an operational data store. So you want to get your data as close to your users as you possibly can. That's our design. That's our goal, or at least one of them. And then also, obviously, having availability. Like, you need your data somewhere else if a region goes down. So that, of course, also speaks to why we replicate everything. So but customers are asking us as well for they want to kind of mix and match as well. Exactly. Some of their data. So even in this space, where we're more of an OLTP or a transactional operational data store, they still kind of want to see that kind of mixed or hybrid approach, if you will.
Yeah.
Around that.
And I think that providing that no copy data sharing within one cloud is one thing, but then scaling that to cross cloud or multi-cloud, or let's say cloud and on-premises, that's another thing. If you have your data sitting, across multiple cloud providers or across on-premises and clouds, and then you want to make sure you don't have to move that data, that's very tricky. And I think this is where another trend or another development is getting popular around some new hybrid approaches that, I think it would be important to first identify that there is this standard hybrid approach that we're used to, when we have either backups in one place and then the rest of the functionality in a different place, when we have some workloads migrated into the cloud and some aren't. But then I think there is a new emerging cloud native hybrid approach with things like Azure Arc, which is gaining a lot of popularity, where we can make some of our local, on-premises or other cloud machines behave like they are an extended part of Azure plane, which is a really interesting aspect. Then if you treat your machines as something that Azure understands, you can use Azure Resource Manager to manage your resources really easily. And you don't really have to move the data in certain aspects. If there are services that work with things like Azure Arc, like we have our database for Postgres and SQL Server, for example. It's one great example. And other workloads, if you dive into Azure Arc compatibility and like how it is actually built, some container workloads, and Kubernetes plays a really big role in that. So they can really simplify the way we work across clouds and across on-premises and the cloud.
So I looked at Azure Arc, I'll admit, very closely. So from understanding, using Azure Arc, you could make these other, say, on-prem compute nodes or clusters or databases or whatever it is look like a native Azure resource.
Yes.
Is that kind of what it is? Okay, yes. So it's more easily addressable. You could add it into a VNet, I guess, and put it on a 10 dot network and address it that way, or do some kind of DNS resolution to that thing and expose some endpoint that's going to get you either at the data or whatever.
Yeah, and more than that, I think it works with some of our managed services. So not just on the machines, but like on the workloads themselves. So I know that we've had functions and logic apps supported too. So you can think of all the functions, running across the on-premises environment or other cloud environments, and on Azure as a part of one control plane. So they're managed from one system, and we don't really have to think about how to coordinate it and how to make it work. It can figure it out for us.
That's basically, so you're extending Azure into your on-premises environment, which is very cool. I mean, that's almost like Inception for a cloud, right? So
yes,
we're gonna inject your cloud and our cloud into your on-prem environment. So yeah, that's very cool.
And I would also compare it with things like, we've already had hybrid solutions like Azure Stack, but they're more on the hardware approach versus Azure Arc is more like a software approach to that. And we can use that together.
All right, now I've got to play more with this. I'm going to need to, I don't know, find some time in my schedule here. I got a question from a viewer here. What's your view on the upcoming data lake analysis update?
Oh, that is a very interesting question, because I'm not sure what is the data lake analysis update.
Not either.
So if you could provide a bit more context there.
Yeah, if you got some more details there on EG, that would be awesome. So yes. You know, one other thing I wanted to talk to you about is, and we were talking about this earlier, is these whole new approaches, this data mesh concept around data modeling. Like, I'm a really data modeling is something I'm certainly passionate about. I mean, as someone that's been working with relational databases for a really long time, and now with NoSQL databases, and having to kind of almost fundamentally relearn how to model data for distributed NoSQL database like Cosmos. It's a topic I give a lot of talks on and try and teach others, because nearly everyone who's new to Cosmos struggles with how do you model data that's going to scale horizontally, to scale out. So I'm curious, can you talk about this data mesh concept? The data
Absolutely. Model? Yeah. First, I want to make sure that people, who hear about this for the first time, about the data mesh concept. So the data mesh concept was founded by Zhamak Dehghani. She is currently Director of Innovation or something like that at ThoughtWorks. And she has written 2 really good articles on data mesh on Martin Fowler blog. So if you Google data mesh and find his blog, you will see 2 of her articles. There are way more than 2, but it's just these 2 were the main ideas that were communicated around the data mesh concept. And I think the main idea is that it is an organizational and architectural concept that changes the way we think of cloud or data architectures, because it focuses around the concept of decentralization, product thinking, data ownership. So decentralized data ownership with product thinking, the concept of federated data governance, and also self-serve shared platform infrastructure. So it does advocate for improving things like data quality, because the idea comes from the fact that usually, when we look at the way we build data systems or distributed systems today, is that there is like one central data lake or one central warehouse, and there are a whole bunch of teams that work with it, put data in it, take that data out of it. And there are a lot of pipelines built on top of that data. And there is a central team responsible for everything in between. So if there's any issue coming up with the data lake and data in any pipeline, they would be responsible for understanding why this field doesn't map to that field, what happened with
That's what data architects want, though, right? They want control.
They want to control everything. They want to make sure that they can always see the data in one place. But it turns out that there might be a bit better way to approach this and avoid the bottleneck that that central data team has become. and focus on improving the quality of that data. Because if we make sure that each domain team has ownership of the data and has ownership of the result that they're providing to other teams, it can improve the data quality, and it can help organizations understand the value of the data and help prioritize areas within the company, to dedicate more resources to the data product teams that are in demand, that we can identify what are the important metrics that each data team can set, and what data they can provide to consumers of that data. So instead of having the pipelines and like ingesting the data and processing the data and putting the data somewhere else, we're actually serving the data and offering it for consumption to other teams that can use it. But I think one of the big misconceptions about data mesh is that the decentralized ownership doesn't really mean that the data needs to be separate and it needs to be stored in completely separate, isolated places, like a separate database or separate data lake. The ownership can be decentralized, but the data can still be stored in a shared system. And I think this is where the self-serve shared infrastructure comes in, is to agree on the platform that can be flexible enough to provide abstractions for the product data teams to build on top of. And that platform, of course, needs to provide very flexible options in terms of data access, some very flexible security, and other things that allows multiple teams to work with that data. Otherwise, it can become really costly if each team decided to use their own technologies for everything. And this is where the federated data governance comes in. So instead of mandating that, everybody should use such and such, systems to maintain data quality, there is a set of principles or guidelines that are globally set across all the teams, and they can make sure that they meet those principles. And of course, it's a big change. It's a big shift for an organization to implement that. And not every company would be, the right candidate for this architecture. But the companies who need to unblock their current bottleneck of the centralized data team and provide more flexibility in terms of change and getting innovation to speed up the process and things like that could really, really benefit from that concept.
Are there any innovations in terms of the self-serve shared infrastructure, or is it really around kind of the governance piece that's where the innovation is happening?
I think right now it's, even though the concept has first appeared, I think, a couple of years ago, it is still super early in the self-serve infrastructure. And what we currently see happening is that, you would still need the data lakes or the data warehouses in that architecture. It doesn't mean that we won't still use those things that we already have. It's just certain features, certain principles that affect how we choose the technology apply. And not every product that we have right now, it corresponds to these principles. For example, to make sure that the data mesh is effective, you need services that support workload sharing and multi-tenancy, because we need to make sure that multiple teams can use that, and rely on that platform. Things like no copy data sharing and compute mobility are the things that affect the choice. I already mentioned the granular access control. So that means row level or column level security, automation and extensibility would really help in implementing things like that. Also, another aspect that goes into the decision-making for technologies would be like things like quotas or limitations or resource counts. So how much you can fit into a certain subscription, or how much data you can use with one instance of a service, because it can really affect how much scale can your platform handle. So I think we will definitely see new technologies who will be like the better fit for the implementation of the data mesh. But we can still combine, and choose the right technologies right now that just would require a bit more work from us, from the engineering perspective, to get things running smoothly. And then we need more abstractions created in terms of providing that layer on top of self-serve shared infrastructure that would allow creating the data products. So I think that there are things like Kubernetes might be a good option, and things like open application model, which still would require a lot of engineering work to get it right. But I do expect companies coming up with like frameworks and models that would help us implement it more easily.
There's so many things that dictate accessibility to the data from a policy perspective, whether it's data residency, whether it's confidentiality. There's got to be others like the maybe it's the level of the person looking at it, right? Like you can, if you're say a certain level employee, you can only get certain scope of data. You can't see like everything.
Exactly.
And then building systems that allow people to either self-serve data, but based upon these kind of policies. I mean, you need something. There has to be something there. You know what it strikes me of? It's like it reminds me of that adage: build services, not apps. Right? So don't build apps, finished apps. Just build services with endpoints, and then let others build their clients on there. Right? This is almost kind of the same. It has that same feel to it, right? Where you're not just throwing up a data lake or a database or even just an endpoint. You're really building services around data, and the different knobs and buttons and levers are all of those different policy things and governance things, privacy, PII, whatever, that you then have as kind of those things that define the accessibility or the I guess if I'm using the right word, but access to the data.
Yes, and this is actually a really good topic within the data mesh concept, because you're describing product thinking. Like, we're not just building one thing, one little application. We're making sure that we're offering that thing as a product to others. And there are some core principles that Zhamak has defined for, like, what does it mean to have a successful data product? And one of the things is like discoverability, like the endpoint, making sure that people can understand, how can we find the data products? And just having an endpoint is not enough. So the products also need to be self-describing.
Yeah.
So we can
need data lineage in there as well. Like, where did this data come from?
Exactly. So providing a sample schema, or like what data formats is expected from that product or service. Then also secure. How do we know that we can trust? How can we trust that data product? And interoperable, to know that it can serve the consumers in a way that they are used to, in the way that they're expecting to use that data. So it can be an API endpoint, like as a service, or it could be like a Kafka endpoint. It could be something completely different that a whole bunch of consumers are trying to use. So that flexibility and product thinking really helps make sure that it's not just a one-off data operation, like a pipeline, but it's something that can be reusable. And then it also enables agility in terms of you can really support innovation there and replace the old implementation with a better option without re-architecting your monolith, because there you have to break ties and cut out pieces of functionality, and it might take years for the new one line of code to get there. But here It's much more easy. But I
Yeah.
think the danger here is that it is a simple concept, but it has a lot in it that could be misunderstood, or that you really need to pay attention to, like, the 4 pillars of it, and prioritize the organizational aspect to make sure that you're not doing things in silos, but it actually creates collaboration and agreement across the organization to enable that success.
Yeah, I think it's definitely a fascinating topic to think about. It's definitely something that we've got to solve, because the cloud has just enabled so much data to be created and just allowed all of this to come together. It's definitely, I think, the next kind of where I see the next big innovations happening is who can solve that problem and make that data discoverable and self-describing, and can easily apply varying policies to it to determine who can access it, or where it can be accessed, or where it can go, that sort of thing. There's a ton of work there left to do. I just sense that there's going to be a bunch of innovation that's
Yes.
happening in this area. And I mean, I know that there's innovation happening. I can see us as a company working on those sorts of things. I'm not going to talk about that. That's someone else's show. But I'll talk about it, but when it's time. But there's it's very exciting, and it's definitely something I am definitely looking forward to seeing develop. I had a question from a viewer: what is the next big thing that we are all waiting is what he's saying. Yeah, Vishwas, I think we're talking about it right now, for sure.
Yeah, and I think that just to highlight another aspect. So in one of my conversations with Zhamak and Bar Moses from Monte Carlo Data Company, Bar asked Zhamak, like, what is one wish you would have for the data mesh, within the next couple of years. And she did mention that she would love to see a foundation around data mesh, to see all the companies collaborate on the open ecosystem and on open standards that could help define, like, how do we actually move closer to the ideal implementation and make sure that we're moving in the right direction. Because right now there are one-off companies trying to, on their journey to implement data mesh and things like that. But having that would probably help scale the efforts and just organize them a bit more. So it's
the right thing to do from a customer perspective. I mean, data, nobody likes migrating data. Nobody likes doing that. That's and if you make that hard for people, I mean, first of all, they already hate doing it, right? So, and I see this from customers that are migrating to Azure or migrating to someone else. That's the part they hate. Generally, the data is they just want it to stay wherever it was created and let it sit there. And so the right thing from a customer perspective would be to do what you're suggesting, and that is make that easier to surface and share, no matter where it is, right? I mean, even certainly within the same cloud, but across the internet and across clouds.
And you also brought up the data lineage concept there too. Mm-hmm. And just for people watching, I wanted to make another note, is that this is another area where we see a lot of innovation happening. And I already mentioned Bar Moses from Monte Carlo Data, and she's been working on a lot of that, where how do we make data reliable and observable? And as with the amount of data growing, it is harder to do in a real-time aspect of this, because there are tools that help us discover some errors, some issues with the data, statically mostly. But she's been working on some really exciting, innovative concepts on how do we apply the data quality / reliability, observability concept to the ever-changing data, and she's been applying things like machine learning anomaly detection to try to find issues in the lineage and try to find the root causes of that. And this also really fits great into the data mesh concept and what we need. It's just one really good example of the innovation that has been happening.
That is interesting, and good use of applying computers to solve a tough problem.
Yeah.
I mean, rather than the way a human can keep up, probably. So using ML and training models to find issues in that that's very cool. That's very cool. A couple of just a comment here, Floyd here. Thanks for having this episode. Thank you, Floyd, for joining us. This has been a pretty awesome talk, I think. Another question here. Let's see, is there any data modeling tool for Cosmos DB? Well, I know of one called Hackalade that's created by ISV out of, I think they're in Belgium. But there's not really tools, so to speak, right? There's no Irwin for Cosmos that's, I mean, we're schema agnostic. It doesn't really matter.
I can chime in just with one idea. Like, it's not necessarily a tool, but I think the main tool for data modeling, like for success of the data modeling in Cosmos, is just the understanding of things like consistency models and how do you want your data to behave. It's not necessarily a tool, but I think it really helps in data modeling, not only with the Cosmos DB side of things, but with any database.
Right. I mean, and the other thing I suggest to people too is, look, the best way to understand what your data model should look like is to understand how you access data within the system, right? Because unlike a relational database where the whole point is to reduce duplicate data and then use relational engines like SQL and Postgres and MySQL and others to join the data when you need it. In Cosmos, you basically just store the data based upon kind of how it's used, which is, like in a relational world, you would take a customer entity, a customer address entity, and store those in two different tables and then join them with a one-to-many relationship between the two. In Cosmos, you would just embed the addresses in the customer container and then just get all of it with a single request, right? I should do my modeling and partitioning talk on this show sometime.
Yeah. And also, I think if people have any ideas in terms of like what they would like to see covered, that would be great if you could write, some suggestions on what maybe doc pages you want to see. If you go to the docs.microsoft.com, find a page in the Cosmos DB docs, and there's a button there, like, provide feedback or something like that. And it opens the GitHub repository with our docs, and you can raise an issue there that would be, directed to the Docs and Learn team, who could prioritize creating the content that you're interested in, which, I think data modeling is really important topic.
It is. It's super important because of the nature of the database. If you don't, a poor model is not going to perform or scale well, just like a bad partition key is not going to allow you to scale well. And these days it's hard. If you make a bad choice, you're kind of stuck with it until you migrate your data into a new container with a new partition key and probably a new model, and and restart your app. We're working on something to make that easier, by the way. I also, another thing I can't share anything about, but we will soon. So, but
this is another reason to watch the show in the future.
Yeah, that's right. There'll be a future episode where I'll share the cool new thing that we're going to do to help customers with that. You gave me a great idea, though. If people have show ideas, just hit us up on Twitter. I monitor our Twitter handle pretty much, well, not 24/7, but for 12/7, I guess. I don't know, half a day at least when I'm awake. So just throw your ideas at our Twitter handle, and I'll look to program additional shows on there. So a follow-up question here. Thanks for your answer. So NoSQL data modeling is an art for running between embedding and referencing in your data. Well, yeah, I guess in some ways. I mean, there is a science to it, I guess. I mean, and you are making a choice between embedding and referencing data. But analyzing your access patterns and understanding the concurrency of those things is really at the heart of how you model data, right? Because you're trying to optimize around the request rather than optimizing around the storage, right? So just remember, relational databases were first proposed or created in 1970 when the cost of a megabyte of data was like $100,000 versus now where we give you a gigabyte of data for, I don't know, 25 cents a month. So the cost of compute relative to storage is completely flipped in the last 50 years. So now it's compute that's expensive and storage that's cheap. So anyway, I don't know if any other topics you wanted to talk about, or do we pretty much cover?
It would be great to just mention, like, if people want to get started with Cosmos DB, what would be the number one way you would recommend them to get started? Like the free tier, or a way to get started that's easy for most people, if you could just mention that.
For sure, the free tier is the way to get started very easily, and of course for free. And we just increased the limits on that. It used to be we had 400 RU and 5 gigabytes for free, and at the last build conference, we upped that to 1,000 RU and I think it's 20 gigabytes.
That is a considerable amount.
Which is, I mean, you can actually run a fairly hefty workload on that amount of throughput and storage, and you know, hey, build a complete prototype app, and then if you're loving Cosmos, flip it over to standard whatever, or autoscale, or even do serverless. I mean, that's also pretty inexpensive as well, particularly if you're just testing things out. I mean, it's literally pay for what you use, right? It's pay per request. So, if you don't use it for a weekend or a week or whatever, you don't pay anything for it. So, so those are lots of, free tier, serverless, lots of good options for starting. Even our emulator, we have, Windows emulator, and now we've got a new Linux emulator as well. It's another free option as well. You can go and build and dev test prototype your apps for nothing, basically on there. So yeah, lots of good ways to start. And then of course, our docs as well. Always the good source of truth for learning about Cosmos. I know people hate reading docs, right? I mean, developers, nobody reads docs.
It's my favorite thing.
What I do is I crack open Visual Studio or VS Code, download, install some NuGet packages and start writing code. And then if I get stuck on something, I maybe Google something and find an answer on Stack, or God forbid, I go and actually hit the docs and then I read the thing. That's the
opposite.
Yeah. Like if I cannot figure it out, it's the last step. But for our service, I really do recommend people kind of read our docs first, because it is such a different beast in terms of what the kind of database it is and how it works and how it's designed, and how you should design for it. So anyway, I'll make my appeal. Please read our docs.
Yeah, I think that I'm one of those people who just goes straight to docs before touching, a product.
You do?
Yes, I love reading docs, and this is the first thing that I do when I discover something new. And I would say that, I think our docs are pretty good. Of course, always happy to hear your feedback around it. We also have a really great visualization of consistency models with a musical scheme, and it's an animated representation of what actually happens when with different types of models. So please click on that link and just explore that. It's really fascinating. Even if you're not using the database, just for understanding like how things work in the distributed environment and what happens with like the message processing. I think this is one of the best representations that that exist out there.
We used to have in our docs this baseball analogy for consistency model, which I never liked because I didn't find it like the only people that would understand that are people in the US, Canada, and Japan, because those are the only countries that have baseball. Well, and Cuba, I guess. Mm-hmm. But nobody else in the world understands baseball. So it always fell flat as an analogy for how to describe consistency models. The notes seems to at least be more, even if you're not a musician, you can kind of follow along with yes. the animation there. So I changed it because that was in the portal, and I took it and put those in the docs and used that to describe our consistency models. Mm-hmm. In there. So, which I think is much more accessible.
Yeah, that's really great.
So. Let's see, a couple more questions or comments here. Any suggestions on the tools that support to choose a partition key? That's a great question, Jarek. Today, there's not. We are working on a partition key advisor, however, that will analyze your workloads and provide recommendations for a partition key. You, of course, need to pick a partition key first, but as you ingest data and write queries, it will analyze kind of the workload, and using a set of heuristics, we're working on providing something there. It's an interesting question. As I said, relational databases has been around for 50 years. So you've got 50 years of computer science in people and engineers building and improving query engines, right? So now you could pretty much write a garbage query in SQL and it'll perform okay because query engines are very good at kind of optimizing performance and making up for where you kind of lack, I guess. NoSQL databases have not been around that long. Only been 10 years or so. And so there's not been as much time, I guess, in building these things like help me partition my data or all these other things that kind of you get when you've got decades of research and smart computer scientists building and improving on that state of the art. But we're getting there, and lots of cool stuff we're working on that's going to help with that and other things as well that we're going to bring to market. So I love working on this team. It's so much fun. You know what? It's because the space itself is relatively new compared to other areas that you see that kind of innovation. Yeah, it can be rougher on the edges in some cases, and particularly hard on people who are brand new to the space, and because the learning curve can be quite steep at first. But because there's so much run room for innovation, it's exciting in that sense. And it's distributed systems, distributed databases. I love this space. I've been working in this area since back in the 90s when I was working on building queue-based distributed systems using MQ series and MSMQ, and building things that would probably look something like a BizTalk, right, with XML encoders and decoders and sending messages over leased line networks, which were even flakier than the WANs that you have today. Networking was not as good. The internet itself was not very reliable or good, and networking itself, 30 years ago in the 90s when I was working in this, when I first started working in this space, it's much better now. For sure. And the fact that you've got a cloud like Azure or any of the clouds that are connected by these WANs that span the whole planet, it's a whole different game these days. So there's still flaky WANs networks, but they're better. So
yeah, and I think that's another good reason to join the Cosmos DB team. And I think we always have some openings on the careers website. Correct me if I'm wrong, but I think people watching this show might be, if they're interested, go check out the careers page too.
Yeah, we actually do have a job listing opening for a PM on my team to do developer relations, like DevRel. It's basically the thing I spend all my time doing right now. Well, I don't all of it. I still have other stuff I have to do too. But we're gonna try and hire someone to help me, because there's a lot of stuff I've been working. It just gets bigger and bigger, right? So, and as the audience for Cosmos gets larger and larger, there's just more and more stuff to do, whether it's doing a weekly podcast or organizing events or social media or writing blog posts or creating videos or answering questions in forums. Yeah, I mean, there's all kinds of stuff, right? It's a fun, busy space. So anyway, well, Lena, thank you so much for joining us this week. This was a fascinating talk, and I know a lot of the people, the comments I see on there are just they really love the show this week. So I'm really excited to have you on.
You inviting me. It's an amazing show, and look forward to watching the next episodes. And inviting other people who are watching online to stay around for your next episodes.
So thank you. And speaking of next episode, so next week we're taking a week off. I am going on vacation, or I'm going to try. So we won't be on next week, but we've got 18 episodes that we've recorded. So if you've missed one, feel free to go onto YouTube and watch another episode. Coming up on 2 weeks, we'll have episode with Thomas on our team. He's going to talk about client-side encryption. This is the always encrypted thing that we announced at Build. So basically doing encryption from the SDK client all the way across the wire into Cosmos. So come and check that out. That should be a pretty fascinating episode. And again, Lena, thank you so much. Just always fun to talk to you. This was a great conversation, covered a lot of great stuff, and I learned a lot. It was
really fun. I really loved the discussion. Yeah, thank you so much.
You're welcome. All right, everyone. Well, thank you, everyone, for joining us this week, and we'll see you again soon. Bye-bye.
See you.